bulk carrier with 27 crew on board was feared sunk in the Atlantic Ocean. The vessel had sent a distress message stating that several of its holds were flooded. Lloyd's Casualty Reporting Service said an empty life raft had been found, but nothing else. Bulk carriers are the workhorses of the world maritime trade, and a high proportion of shipping losses are amongst them. Between 1989 and 1991, more than 10 vessels sank every year, and many more have been found to be severely damaged. Analysis carried out by classification societies reveals that previously damaged vessels become casualties. The most common cause of damage is corrosion, which weakens the ship's structure. Corrosion increases with age. A number of cargoes, such as coal, with high sulfur content, cause rapid corrosion of the hold. Corrosion increases when the protective paint coating of the steelwork has been worn or wasted away. Corrosion can be reduced by keeping the holds well painted. Cleaning thoroughly after a corrosive cargo has been carried, and by rinsing the holds with fresh water whenever possible. Wasted steelwork, when neglected, has been the basic cause of most bulk carrier losses. Other causes of losses are use of poorly coated high tensile steel, nature of cargo, failure of hatch covers, flooding of holds, possible shift of wet cargo. Heavy weather conditions have been the main contributory factor in most of the accidents. Heavy swell causes hull vibration. Panting and poundings lead to structural failure. Although ships are designed to withstand this, a weakened ship is at a greater risk. Modern ship construction uses high tensile steel, which is thinner and therefore more flexible. Uncoated or inadequately maintained high tensile steel is vulnerable to corrosion. Wasting due to corrosion increases the stresses in the structure. Prevention of corrosion is thus of utmost importance. Ore, due to its high density, does not occupy much space in the holds, and therefore the water pressure acting on the ship's side is not balanced from within. as is the case while carrying coal or grain. In a badly maintained vessel, bending will loosen the top and bottom ends of the frames. Because of these deficiencies, seawater may enter a hold through fractures in the side shell. Hatch covers, which are badly maintained, are an important cause of casualties. If the hatch covers have not been correctly cleated down, in heavy weather they may spring open, allowing the flooding of a hold. Flooding of the number 1 hold is a major cause of bulk carrier losses. A hold loaded with iron ore has a lot of empty space. A large quantity of water can enter the hold, increasing the trim by the head. Other hatches will soon be awash, increasing the risk of flooding numbers 2 and 3 holds. Once this happens, the ship may nosedive and sink without much warning. Certain types of cargo liquefy easily and can shift in the hold. The ship may capsize, or hull and frame structure may collapse. A ship is like a beam supported by buoyancy and subjected to load due to its weight and cargo. The buoyancy and weight of a vessel are not uniformly distributed. This uneven distribution causes shear forces and bending moments on the hull girder, depending on the pattern and amount of loading. Loading, when badly planned or carelessly done, is a serious cause of damage to ships. Local overloading is putting more cargo in one part of the ship than it was designed to carry. One cause of this problem is block loading, when 2 or more adjoining holds are heavily loaded. A second cause is putting a greater tonnage of cargo into a hold than it was designed to carry. This may happen if the ship loads to tropical marks and carries minimum bunkers, or if a mistake is made and more cargo is loaded in a hold than was intended. Local overloading damages ships. If the planned loading is not shown in the loading manual, the owners should be asked to clear it with the Classification Society. The chief officer should plan the loading, taking into account the deballasting capacity and stability data of the vessel. The number of chutes available, their height, and the depth at berth should also be considered. The loading instrument provides valuable support in loading and unloading operations. If it is available on board, use it extensively to obtain maximum benefit. Three good reference books are available to help the officers of bulk carriers. The Bulk Carrier Code from the International Maritime Organization provides basic regulations and guidelines for carrying bulk cargoes. Guidelines from IACS give detailed advice on surveys, assessment and repair of hull structures of bulk carriers. Bulk Carrier Practice, published by the Nautical Institute, is written for the officers of bulk carriers and explains all the jobs such officers must do. Steelwork is damaged when heavy cargo grabs strike it. Bulldozers and hydraulic hammers also cause such impact damage. Care must be taken while using them, especially in number 1 hold, because of its special construction. Stevedores must be properly supervised. Inspect before sailing and during ballast passage. Attention must be given to damage found. Are these losses inevitable? No. This is what you can do to prevent them. Ship's officers should make a thorough close-up inspection of all holds at least once a year, keeping within hand's reach of the steelwork. Holds must be clean, free of cargo residue, and scale must be removed to allow inspection of sound steel. Ship's officers should look for damage caused by corrosion, namely accelerated wastage and possible grooving, fractures in the web of the frames and end brackets, buckling of the side shell frames, detachment of frames from the side shell, fatigue fractures, deformations due to operational procedures, for example, stevedore damage. Major areas where structural weakness occurs should be examined as often as possible. They are main side frames and their connections, boundaries of transverse bulkheads and bulkhead stools, cross-deck structures, hatch corners and hatch coaming brackets, localized cracking and buckling of web frames, and breakdown of coatings in water ballast tanks, the intersection of the inner bottom plating and the hopper plating. Records of inspection and action taken by ship's personnel should be maintained with reference to structural deterioration, leakages in bulkheads and piping, conditions of coating or corrosion protection, identified suspect areas, previous repair history. Bulk carriers may age fast, but seaworthiness can be extended through the efforts of all concerned. Despite precautions, some damage may occur. It must be detected and repaired. Classification societies have recommended minimum requirements for close-up survey, depending upon the age of the vessel. Access to the ship's side frames is a major problem, and various equipment is used to overcome that. Equipment used includes ladder for lower brackets, mobile scaffolding, cherry picker, catwalk hung from a crane. While inspecting, necessary safety precautions should be strictly followed. Look after your ship and prevent damage due to corrosion, by stevedores, other external agents, by local overloading, and defective hatch cleating systems. Slow down and do not force the ship when meeting heavy swell. Inspect regularly for damage and deterioration, and when it is detected, have it surveyed and repaired. Remember, 1. Bulk carriers with weakened structures become casualties. Prevent this. 2. Prevent the most common causes of structural damage: corrosion, stevedore damage, local overloading. 3. Despite precautions, some damage may occur. It must be found, reported to owners, inspected and repaired. 4. Inspect regularly for damage. When damage is found, have it repaired. 5. Follow Classification Society recommendations.